In Chapter 9, we are looking at the transfer of thermal energy. For the learning outcomes, we're going to focus on what is heat transfer, what is conduction, convection, radiation, and the applications of heat transfer. So what is heat transfer? Heat is transferred, or thermal energy is transferred from a region of higher temperature to a region of lower temperature until thermal equilibrium is reached. And at thermal equilibrium, the objects have the same temperature, and therefore there is zero net heat transfer. Now, it is important that you avoid using the term heat energy because heat is already a form of energy, so we do not say heat energy. It is recommended that you write heat as thermal energy. Alright, so use thermal energy rather than heat. Now, there is a important distinction between the word temperature or the term temperature with thermal energy. So temperature is a measure of the hotness or coldness of an object, while thermal energy is a form of energy related to the total Ke of the molecules of the object. Now, let's look at the process of conduction. Conduction is the transfer of thermal energy through a medium without any flow of the medium. And in non-metals, conduction is done through the process of passing of vibrations from the more energetic molecules to the less energetic neighboring molecules. And for metals, conduction is done through the movement of free electrons. So conduction occurs in solid, liquid, and gases, but very slowly in liquid and gas because the molecules are further apart and they are free to move, and therefore it is difficult for the passing of vibrations to occur. So for example, here at the top of the test tube, the water here is boiling, but the ice remains solid, it doesn't melt. And the reason for this is because convection currents, which we'll do later, there are no convection currents set up below the hot water, and water is a poor conductor of heat. So thermal energy is transferred very slowly from the hot water to the ice, and therefore the ice does not melt. So conduction is only affected by whether the substance is a solid, liquid, or gas, or whether it's a metal or non-metal. It is important conduction is not affected by color or texture. Okay, so do not confuse conduction with radiation. Convection is the transfer of thermal energy in a medium by the bulk movement of molecules due to differences in densities of the fluid. Now, let's talk about water. So what happens when water is heated up? The water will expand, it becomes less dense than the surrounding water, and it rises. Then the denser, cooler water at the top will sink. And the cycle repeats, and a convection current is set up to heat up all the water uniformly. So that's convection. Now, when you answer questions related to convection, you must mention the differences in densities. You have to say the less dense hot air or hot water rises. The denser, cooler air or water sinks. Okay. Now, it is important that if this is a question about water, that you do not use air. If this is a question about air, you do not use water. Radiation is the transfer of thermal energy in the form of infrared without a medium. Now, there are many factors that affects radiation. So the color of the surface, the texture of the surface temperature, and the surface area. So this will affect whether they are good emitters, good absorber, or poor emitter, poor absorber. Now, a good emitter will be a good absorber. A poor emitter will be a poor absorber. Now, it is important that you do not use conduction here. Conduction is not affected by color or texture. So, giving an example, you have two cans containing hot water. So this is a question about losing heat. The hot water will lose heat to the cooler surrounding. And here, the black tin, the black surfaces are good emitters of radiation, and therefore it will promote heat loss from the hot can to the cooler surrounding air by radiation. Therefore, the temperature will decrease faster. Now, let's look at two foils that are being heated up this time. This time, it is about gaining heat. So the black surfaces are good absorbers of radiation. Therefore, they promote heat gain from the hot air to the cooler aluminum foil by radiation, and therefore the temperature rises. Let's look at some applications of thermal energy transfer. There is a certain format you should use in your answer. You should describe the properties of the material and whether that material promotes or reduces heat gain or heat loss, and by which process. So, example, cooking pots. Cooking pots are made from metals because metals are good conductors of thermal energy, and they promote heat gain by conduction. So the pot becomes hotter faster, and therefore they can cook the food faster. So for example, polar bears have white fur because the white surfaces are poor emitters of radiation. Therefore, it reduces heat loss by radiation. Of course, trapped air. Air is trapped in the fur, and air is a poor conductor, and it reduces heat loss by conduction. Now, in hot countries, people wear white shirts because white surfaces are poor absorbers of radiation, and so it reduces heat gain by radiation. Now, heat sinks are used in computers. Heat sinks are usually black with fins because the black surfaces and the large surface areas of the fins are good emitters of radiation, which promote heat loss by radiation. So this causes the heat sink to be cool and be able to be used. Now, let's look at a thermal flask. Let's look at the plastic stopper. The plastic stopper is a poor conductor, and therefore it reduces heat loss by conduction. The trapped air. Trapped air is a poor conductor, and it reduces air movement, so it reduces heat loss by conduction and convection. Vacuum. Vacuum is a perfect insulator. It will reduce heat loss by conduction and convection. Now, the silver color surfaces are poor emitters, so they will reduce heat loss by radiation. And the cork at the bottom is a poor conductor of thermal energy, so it reduces heat loss by conduction. Therefore, the hot liquid stays hot inside for a longer time. Now, the reverse is the same if you are using cold water. Then you will say it reduces heat gain by conduction, convection, radiation. In a refrigerator, the freezing unit is usually placed at the top of the refrigerator, and the reason is convection currents are set up below the freezing unit because the denser, cooler air sinks and the less dense warm air rises. This cools all the air uniformly and efficiently. In reverse, for the kettle, the heating element is placed at the bottom of the kettle, The reason convection currents are set up above the heating element because the less dense warm water will rise while the denser cooler water will sink. So this will heat up all the water uniformly and efficiently. Let's do some practice questions. In cold countries, people wear coats that are designed to reduce the rate at which thermal energy is lost from their bodies. The material for some coats is made from a layer of thin strips of silver-colored plastic between two layers of fabric as shown in the figure. The plastic strips trap small pockets of air between them. Explain why the layer of silver-colored plastic strips reduces loss of thermal energy by conduction, convection, and radiation. So let's start with the first one, conduction. And in the passage, we can identify plastic and air. So plastic and trapped air are poor conductors of thermal energy and reduces heat loss from the hotter body to the cooler surrounding by radiation. So convection. Convection talks about, in the passage we can see it traps small pockets of air. So trapped air reduces air movement and reduces convection currents, which reduce heat loss from the hotter body to the cooler surrounding by convection. And for radiation, it will be the silver-colored surfaces. So the silver-colored surfaces are poor emitters of radiation and therefore reduce heat loss from the hotter body to the cooler surrounding by radiation. Now, in this example, we have to use emitters. We cannot use absorber because the people are hot and the surrounding is cold, so the people will be emitting heat, and that is why we have to use the word poor emitters of radiation. Now, in this question, there are two cans A and B. They are filled with equal masses of the same liquid at a temperature of 75 degrees Celsius. So can A has a polished silver surface, while can B has a dull black surface. Both cans are placed on a bench, and the temperature of the substance in each can is measured every minute. The variation with time of the temperature of the substance in can A is shown. Describe how thermal energy is transferred from the liquid to the surrounding. So there are many ways the thermal energy from the liquid is transferred to the surrounding. So thermal energy is transferred by radiation in the form of infrared radiation from the liquid to the surrounding. Thermal energy is transferred via conduction. Air above the water is heated up and convection currents are formed. The hot air then transfers the thermal energy to the lids. Thermal energy is also transferred by conduction from the hot liquids to the can, to the lid, and then to the surrounding air. So all three processes occur: conduction, convection, and radiation. Now, when you explain, you have to describe, you have to give a little bit more details, and do not simply just write conduction, convection, or radiation. Do not just focus on one processes, but you need to describe all three, and with a little bit of description, a bit more details involved. In part B of the question, sketch the variation with time of the temperature of the substance in can B for temperatures between 75 and 35 degrees Celsius. So can B has a dull black surface. In this case, we're going to use emitters because the liquid is hot and the liquid will lose thermal energy to the cooler surrounding. So the dull black surfaces are good emitters of radiation, and so it will promote heat loss from the hot liquid to the cooler surrounding by radiation. So this will cause the temperature of the substance to decrease faster. So the first part of the can B, it will have a steeper gradient, it will have a shorter horizontal line, and again it will also have a steeper gradient compared to can B. In this question, there is an electrical heater that is placed near the surface of some water in a beaker. There are two temperature sensors, sensor A and sensor B, that are placed in the water. Sensor A is near the surface of the water, sensor B is at the bottom of the beaker. Figure B shows how the temperature recorded by each sensor varies with time. So explain why the temperature recorded by sensor B changes very little. So there are no convection currents that are set up below the heater. Reason: the less dense hot water will rise, and water is a poor conductor of heat. Therefore, heat transfer from the heater to the sensor B is very slow. Now, there are two reasons you need to explain for this question. Alright. Now, it is wrong. You will be penalized if you use air instead of water in this question, or you say hotter water sinks. That is wrong, and students who write that will be penalized. Suggest why the heater should be placed. Suggest where the heater should be placed so that both sensors record approximately the same temperature. To do that, we are going to focus on the position of the heater. So place the heater at the bottom of the beaker below sensor B. Now, it is wrong to say to place the heater in the middle of the beaker or to move the sensor A and B. Okay, because the question was very specific, where should you place the heater, and so you shouldn't move the sensors. These questions, there are two kettles. The bodies of the kettles are made from different materials. Kettle A is made from shiny silver color metal. Kettle B is made from white plastic. Discuss the suitability of each material in reducing heat loss from the kettles when they are used to boil water. So in this question, you have to describe or discuss all the 5 properties of the materials. So shiny, silver color, metal, white, and plastic. So shiny, silver, and white surfaces are poor emitters of radiation. Because the water is hot, it will lose heat to the surrounding. That is why we are using the term emitters of radiation. And they will reduce heat loss by radiation and therefore are suitable material. Now plastic is a good insulator, so it will reduce heat loss by conduction, and also again it is a suitable material. Metal, on the other hand, is a good conductor, and it will promote heat loss by conduction to the surrounding, and therefore it is not a suitable material. So in this question, you have to be very specific to describe the property of each material and discuss whether are they suitable or not suitable in reducing heat loss.